Uh, hello guys. Welcome back to my YouTube channel. My name is Kakembo Owen Ntambi, and this week I'll be taking you through another project for AI. Basically, I'm going to be taking you through AI through my project. So I managed to get a partner. His name is called Jerome, but for this video, it's only me going to be presenting. So there are some other details, but I don't think they're needed. So starting off, I'm going to start by telling you about the problem statement. It's basically almost the same project, though we made some minor tweaks. So we managed to narrow down the problem to stress, and we found out that in society, most of the major issue in society is stress. So we thought about it and thought of an AI that can help combat this stress or reduce it in certain ways, like relief activities like yoga, meditation, taking walks, or any other activities that you feel can relieve your stress. Then we also thought about it in the sense of the AI literally talking to you, asking you questions based off your facial expressions. Like if I'm sad, it will pose a question of if I'm fine. If I am fine, then it would proceed, I would proceed on. But if I persist with the sad face, then it would ask again, and then the third time. Uh, so basically, after it asking all the three times, and either if you say yes, that you're not sad, sorry, if you say no, and you're not sad, then it will stop. But if you are sad, then it will go on to recommend one of the relief activities. So we went on to identify an open data set from one of the links like Kaggle, went and identified from Kaggle human faces. And from that data set, we're majorly looking at features like the sadness in someone's facial expression, the redness of their eyes, the fatigue or exhaustion, the teary eyes, and some other factors. So we considered some factors like the variety of emotions in the data set, the human faces, the completeness of the data items. We also went on to consider the various age groups so that we could increase the reliability and accuracy of our data. Then we also took into consideration the quality of the images in the data set. Then, as I said earlier, the 5 important features we looked at were the redness in the eyes, the teary eyes, sadness, signs of aggression, and fatigue and exhaustion, among the many others. So we are going to look at three things: Bayes theorem. We're also going to look at Bayesian networks and naive Bayes. So I'm sure most of you all have heard of Bayes theorem from probability and statistics. So Bayes theorem, in AI, it's used to determine the probability of an event with uncertain knowledge. And basically, we are trying to, I can say, unlearn what you have learned. I think that's how I understand it. in that we have the equation, base equation of probability of A given B equating to probability of B given A. We're literally inverting. Then we multiply that by the probability of A, divide by the probability of B. So we can take that equation and use cause and effect in AI. So it will be the probability of cause given the probability given effect equating to the probability of the effect given the cause times the probability of the cause divided by the probability of the effect. So if I'm to give an example of Steve, I can give the person the name Steve, and Steve is a librarian. No, sorry, he's not a librarian, but there's a probability he's either librarian or a farmer based on the evidence of him being timid, shy, introverted, helpful, and kept to himself. Through that evidence, you may think that he's a librarian, but uh, if we take the number of farmers to to librarians, then would have, if I'm to use a number of maybe a ratio of 10 to 200, 10 librarians to 200 farmers. So in Bayes' theorem, we're going to get the hypothesis, which is Steve assuming that he's a librarian, given the evidence, which will be our effect, the evidence of the case study I've given you. Then we shall equate that to the probability of the evidence given the hypothesis times the probability of the hypothesis divide the probability of the evidence. So there are terms you have to get in Bayes' theorem, especially in AI. That is the probability of A given B, which is the answer, and that is called the posterior. Then probability of B given A, which is the likelihood of the evidence. B, if the hypothesis A is true. Then there is probability of A, which is the prior probability. Then probability of B, which is the marginal probability. So there are various applications of Bayes' theorem in artificial intelligence. And one is that it's used to calculate the next step of a robot when it has already executed one step. So it also helps in weather forecasting, and it's also used it was also used in solving Monty Hall's problem. For all of you who don't know Monty Hall's problem, that is, I'm not going to explain it because I'm timed and I'm limited. But basically, it was an American television game show. Like, I want to say that deal in that the Monty himself gave 3 doors, and the contestant had to pick one. I don't want to go into details. You can read about it. It was an interesting game show, though. I was never able to watch it. So there is naive Bayes. So naive Bayes is based off Bayes' theorem, and it's used to solve classification problems. Then the other thing is that naive Bayes, it assumes that all predictors are independent and assumes that the presence of one particular feature in a class does not affect the presence of another one. So if I'm to give the example of a fruit, maybe an orange. So there are various features that an orange has, and one of them is the shape, which is round. Then the other feature is it being the color, it being orange. So in naive Bayes, we're taking those features as two independent things, if I'm to say that. Then it also gives every feature the same level of importance. So under naive, there are various advantages and disadvantages, but the main advantage is that it's quick and saves a lot of time. Then among the disadvantages, is that because of it assuming um, that the features are independent, and yet in real life that is not that rarely happens, that features are independent of each other. Then in Bayesian, we have Bayesian networks, which are a type of probabilistic graphical model that can be used to build models. So the thing about Bayesian is that it can be used to get accurate results. So take the example below of wind, lottery, rain, and wet ground. So wet ground depends on the rain, but wind lottery is independent of either, cause in common knowledge, or basically you can't win the lottery because it has rained or it has not, unless, well, you're a black magician. But so we have the probability of the lottery, the rain, and the wet ground, which is equal to the probability of the lottery, since it's independent, and then probability of the rain times the probability of the wet ground given the rain, since the ground can be wet due to the rain or other reasons, like maybe you are washing your car on the grass, or maybe you have sprinklers. There are various reasons which can cause the ground to be wet. But in Bayesian networks, we are generally building a network of probabilities, in that the ground can be wet due to various reasons. So that causes a network to be built. So we have advantages of Bayesian, and the most the the most common and important of them all is that it creates models for complex and uncertain models. Of course, there are others of which it's used to develop a mathematical, logical, robust framework for certain landscapes. Then it eases in incorporating data from heterogeneous sources and varying accuracy levels into a mathematical coherent model. There are also disadvantages of Bayesian, and one of them is that it's complex to build those various models, in that you may miss one, or yeah, majorly you can miss one if you're not careful. And in AI, if we're to get accurate data, then we need accurate input. So we have differences between Bayesian theorem and naive Bayes. Naive Bayes, as we saw earlier, is that it assumes conditional independence, unlike Bayes' theorem. And naive Bayes is faster than Bayes' theorem, since it deals with less complex data, and has a smaller data model. Then there are differences between naive and Bayesian networks. So in Bayesian networks, we're trying to model the relationship between features in a very general way, while in naives, as we said earlier, it assumes that every feature is independent. So that brings us to the conclusion of this video. But basically, naive Bayes and Bayesian networks all come from Bayes' theorem. So if you understand Bayes' theorem, it's not hard to understand naive Bayes or Bayesian networks. And you can pause the video to get the references given for further study. I would like to end this video. Thank you so much. Peace.